Review just before assessment, Unit 7, assessment 1, Part 1 and 2. Here it goes. Over here, if I were to change that, everything that I saw that C is a radical 3, how about I just do that in red? A little red action, a little red action, so they can see where it happens. So left radical 3 will be an x over plus a y for that whole thing equals a negative x and a 2, and that's a negative sign in front of that whole thing. Sure, negative, and let's put a 2 on that. Pause and look at the what's the word? The substitution. I see if you're at peace with that. If I ask you to solve this for y, I feel like a lot of you would be okay. Basically, grab this fraction, toss them on the other side, and you're like technically done. You could say I solved it. You have solved an equation when the variable that you want to isolate is alone. Now, technically, you have to simplify what's on the other side, but if you want to argue with some teacher, you'd at least you get half credit for sure at the end of the argument. Here goes. So do this. Step 1. I'm going to send you to the other side, as I said I would, leaving just the y equals a negative, sure, everybody can go back, negative x, the x over 2 that I put on the other side. When you move something to the other side in this format, like a plus or minus situation, whatever the original sign was, it becomes the opposite. Opposite of minus is a plus. Pause. Hey Thomas, how do you add two fractions? Step 1, or a whole number in a fraction. Step 1, you put this guy over 1 to make him a fraction. Get common denominators by multiplying the bottom by 2's. You wind up with a negative 2x over 2 plus x over 2. Now, for those of you who may be writing, yeah, you could have it as notes. I did it once in college where I decided I'm not going to write notes today. Because when I wrote notes, I couldn't learn while I was writing. So I just watched, like, oh, I see what he's doing. It worked out good. It's just at home, when I got home, I didn't have any notes to work with. All over 2, negative 2 plus 1 is a negative 1. Hopefully they can see that. If they can't, I'm not saying you shouldn't be in algebra 2B. I'm just saying you forgot from back in the day. Final answer here. Negative x all over 2. Hopefully they can see negative x all over 2. Pause, right, look. So is this the answer? That's a take 2 for the people at home. No, it's not the answer. You know, here at the beginning, wherever I see an x, it has to be a radical 3. Wherever I see a y, it has to be the cosine x. So here's the actual answer. Now in blue, actual answer in blue, I got a cosine x. Shoot. Let's see if they can see it here. Y equals this negative x all over 2. That's the thing that's coming over here. Cosine x equals, let's need more space. Cosine x equals, let's see, radical 3 is the x, so a negative radical 3 all over something, all over 2. Let's put a box around that and figure out what that even means, because that's not the answer. That just helps me get the answer. Take a look and see if you're okay with this. The y is alone, the y is alone. The y is cosine x, the y is cosine x. 2. Radical 3 is really the x thing for the purpose of substitution. There's a negative x on top here, so there's a negative 3 thing on top there. All over 2 here, all over 2 there. Like a puzzle, just identify the pieces. All right. Here actually comes the math part that you're going to need your chart for, that you won't get to use until the end of the test. Step 1. What's a cosine that puts a 3 on the top? Make sure the attendance is all the way down. What's a cosine that puts a 3 on the top? Cosine, count from the top. 1, 2, 3. The next finger is a comma. So here I go. One thing I know to have a cosine with a 3, it's going to be this finger here. Can someone say what this finger is?
30.
30 or 3. Now, if I start on my test, and I will give you partial credit for this 30, even though I know it's the wrong answer. 30 degrees starts it off. When you get to look at your chart, you're going to look for 30 degrees, and you're going to see, okay, is there a negative radical 3 over 2 at 30 degrees? There won't be. So that 30 on the little circle thing, cosine either goes to the right with a plus sign, or it backs up and goes to the left. Goes to the left with a minus sign. Left or right, that's the only way you get cosine. Now watch this. 30 degrees, unfortunately, is over here. With the parentheses, too much information. Okay, just skip this one. How about that? Skip this one. It's not worth the 2 points. Cosine, we know, is the first thing. Sine is the second thing. If cosine were, to get to 30, cosine would have to be positive, and sine would have to be positive. What the heck is he even talking about? The old test, you know, you got to go here and up to get to 30. Go plus, and then plus. I'm saying this right. I'll just say it this way. In order for cosine to be negative, you have to go to this side of the circle. You either have to back up and go up for cosine to be negative, or back up and go down. But you got to back up first. A long time ago, there was a song about this very same thing. It was like, something, something, back that thing up. You know that song? Yeah, that was about cosine. You good, back that thing up. I've never seen the video to it. I'm not sure what that video looks like. I've never been to an occasion where they're actually doing it. But I'll say this, just for the record. Good. All right, this is a calculated question. Name all the values of cosine and sine are equal. Yeah, but it'll look something like this. I'll sketch it real fast, you know. 1, 2, 3, 4. 1, 2, 1, 2. I'm impressed that I can do this this fast. Sine in red, cosine in green. Sine, you're going to go up and down. Of course, you're going to need to do either 360s or you got to put the real numbers, 360 or 2 pi, and then put them all in. Your calculator would have this, and of course, this guy here, what are you? You're like there for cosine. All right, so the question is, when is sine and cosine equal? They're equal right here and right here. Where do they crisscross? The second question about the reciprocals is, where is 1 over cosine and 1 over sine? These are reciprocals. This is what the cosecant. Excuse me, and this guy is secant. This is like genius. I feel like I'm a genius, but rather than just remembering it. Where do these two guys meet? Your calculator is going to give you these. I think the cosecant, the red stuff in the calculator, I believe it does something like this. I think it does like a U, and a U does some weird U like that. This weird U is that thing, and then the green, I think they do a U like that. If I'm guessing the answer, the reciprocals are never equal. This is my guess. The sine and cosine, they're equal at least in 2 places. And you need to name it. In other words, if it was money, you'd be 25, you'd be 90, you'd be pi over 2, but they don't meet right here. They're not meeting right there, they're meeting halfway. But what's halfway? Halfway is going to be the 45. 45 for you and halfway between here, which is something. But again, I'm giving you credit, like I'm giving you, hopefully it's worth 3 points. I'm giving you 2 points for producing pictures. Where are the pictures? In your calculator. Pause, take a look at it. I'm going to show you some regular inverses, and then I'm going to make a point. The answer is they undo each other. They undo each other. And here's what it means. Now let's see if I can do this fast. We'll go 2x, 2x, 2x. How about 2x equals 8? 2 times x equals 8. Hey, Thomas, could you solve this equation? Sure. I'll do the reciprocal of 2x. In other words, instead of multiplying, I will divide. I'm not the reciprocal, the inverse. The inverse of something is the reverse, the opposite. So multiplying by 2, well, if I want to undo that, I divide it. Okay, so I just did the inverse. I undid. I know these words can't be right, but undo, undid, you figure it out. It's like slang in a math class. So I undid. Let me undo another one. X plus 2. Should have done blue. X plus 2 equals 8. Hey, Thomas, could you do the inverse of that? Yeah, I'm going to undo it. I'm going to subtract 2 on both sides. I'm going to wind up with x equals 6. Okay, I undid it with the inverse. Well, the same is true in the world of tricks. It goes like this. Hey, Thomas, you got a cosine x, and it happens to equal 1/2. You need a calculator to do this. Thomas, could you solve that? I sure can, because I'm thinking genius. 10,000 hours of this, 20 years of teaching. It has to be. Oh, this is 10,000 hours of the same thing, though. In any case, hey, Thomas, could you undo that? Sure. Here's what I'll do. I will use the inverse. I don't even know if I need the x on it, but I'm going to put it there. I don't think I need that x on there, but I'm going to put it. I'm a cosine exit on this side, and I'm a cosine exit on this side. When I cosine exit on both sides, here's what happens. These two guys cancel, whatever that means, leaving me just with x equals whatever the calculator says, 1/2, or I hit blue button, cosine, I'll have the inverse, type in 1/2, hit enter if it's in radical mode or radians mode. It should spit out an answer. But I know cosine, I need a 1/2 or 1 on the top, so I'll fold you. You're a 60. I did it with my hands, but I think the calculator will do it. What is he saying? The inverse, cosine, arc, cosine, secant, whatever name you say it, it undoes the other guy. So if I did a sine of the same, sine 45, sine, sure, do real fast, go. Let's do sine, let's do theta. Hello, theta. Equals, it doesn't matter, the letter could be x, theta could be f, equals, let's make you a radical 2/2 because you're so famous. Hey, Thomas, you need to get rid of the sine. How can you get rid of the sine? You just do the opposite. You do the inverse of it. What's the inverse of a sine? It's the same word because they couldn't make up something new with what looks like a negative exponent, but we don't say it. We say arc sine, sine inverse of x. We don't never say sine to the -1 power. You do that, just don't say my name after you say that because I don't want them to think we're related. All right, here we go. What happens, Thomas? These two guys cancel out. Oh, I'm sorry, not an x. It should be a theta. Switch to theta. Hi, theta. Theta is just a letter in Greek. I'm left with theta equals, of course, I know if I need sine coming from bottom 1, 2, I know that's a 45. All right, pause it. The answer is circled. For these guys, you're putting in y equals, obviously, cosine x. His partner is y equals 1/cosine x. Parenthesis, do they need a parenthesis? No, I don't think they do. You do? Well, why?
Because they automatically put the parentheses after the cosine.
Oh, it does? So you have to close it off? Yeah. Okay. You know, I would have two people try without closing it off. Usually, a non-closed off parenthesis messes up things if something comes after and nothing comes after. Usually it should. Okay, you got two pictures. Here's what I'm going to say. All right, so it shows a picture. And that way when you're describing 1, 2, 3, 4, on the original, there's original, then the new guy, I'll put him in red, he wants me to move over 2, whatever 2 is. Okay, so the sketch will be a little difficult on this because 2 to the left 2, and 1 up. Here's 1, so you're up here by 2. So the new line cinema is going to be here, and then you start your thing again. 1, 2, 3, 4. So this picture says I know what the difference is, but it's not describing it. So I guess if I were taking the test, because I'm sure of what I would say, I would just say it shifts it 2 to the left and down 1. How do I say this so I sound smart? The new picture, the transform picture, the transform graph, the graph has been transformed. The new graph, the transformation, the transform graph, the new graph, yeah, compared to the parent function, the new function has been shifted 2 to the left and 1 down. Extra fast, swig swag. What do I need? 1, 2, 1, 2, 1, 2, 1, 2. So what are you? 1, 2, 3, 4. I need to shift you 2 to the right. Where's pi over 2? Pi over 2 is probably 90. Yeah, because you're pi. Your pi here, your pi over 2 here. So I need to shift the original thing right here. So you're the new starting point. So here it comes. 1, 2, 3, 4. And you need me to jump up to 2. Let's see what I got here. I need 50 cents, 25, 75, money above 25, money below 75. Where are you now? Oh, here we go. Up and down and up. So the new amplitude is a 2. It's a 2-story building now instead of a 1-story building. And they had to move it down the block a little bit to make parking for the handicap. All right. So I don't know if they call handicap. Talking about he and dog. Here's the original. I want you to graph all these. It's not saying to graph, but let's say if you had to. It would say, what would happen to the original if they asked you to do this thing here? So here's the good news. Whatever's in parentheses tells me to move it, shift to left or right. In this case, it's the opposite sign, so I'm going to move this thing to the left. Pi over 6. So the good news is I don't have to actually graph this. I don't know what pi over 6 is. 33? I don't know what pi over 6 actually is on the little graph thing. But this tells me, if I were saying this answer, shift function pi over 6 to the left. That's what I would write down as my answer. This guy moved the picture down 8. This guy shifted to the left 3 and down 2. And this guy, negative, flip it about the x-axis, so flip the picture. Again, one of your things on the actual Unit 7, Session 1, you see how they have this pi over 2? That means when you get your final answer, it needs to put in radians. So let's say you decide this answer, I need a 3 on top, 1, 2, 3. Say it's 30 degrees, and you put your 30 degrees. And you even get the part, which might be 150. Am I going to give you full credit? I am not. Why am I not? They want it in degrees, I'd rather in radians, so you have to do this 30 pi over 180. If there's zeros there, you can cancel out the zeros. If you don't know how to cancel out zeros, leave them there and just divide the top and bottom by the number that goes into both of them. 1 pi all over 6. I'll accept either one of these, but the point is this guy needs to be pi over 6. When are you going to make it up? Today, tomorrow, so you can take your test. Not next week, it's going to be too long. You forget all this stuff. Woohoo, that'd be great. Let's try that. Oh, that'd be even better, yeah. Let's do that. Okay. You have to do it to both of them. Do it to 150 as well. All right, 35 seconds, what you got?
I know you got 30, but I should go 150.